Good evening, everyone. Good afternoon. I'm Mike Maines. I'm a residential designer, building science consultant, contributing writer for Fine Homebuilding. And I started the BS and Beer concept basically, or I started the, I stole the concept from Dan Kolbert, who's on the call, and Steve Constantino, who are doing something similar in Portland. For the last 10 years, just as a way to get together and share building science knowledge and have a beer or a beverage of your choice. Our goal is just to share building science knowledge far and wide and have fun. My notes are on my other screen if I'm not facing forward. We're really excited that participation is growing. I'd like to thank everybody who has been on these before with us and everybody who's coming in new. Really appreciate Green Building Advisor and Fine Homebuilding promoting us as our new media partners. Very excited about that. And we really, the goal here is not to try to get rich or even make any money at all doing this. It's really just to discuss building science, share knowledge, and to have some fun doing it. So hopefully everybody has a good time. We really encourage you to start your own local groups. This is great, but really we think it's best to meet in person with your local community. It helps build community. Your local concerns will be different than what we can discuss here on a national platform. Feel free to use the name BS and Beer or any version of it. It's not copyrighted. And if you do decide to do one, we would appreciate knowing about it so we can sort of keep a list and help promote it. Let's see. I think that's it for me. I'd like to introduce our other hosts. Emily Mottram is an architect here in Maine, and our new host, Travis Brungardt, is a builder in Kansas City who runs the Kansas City BS and Beer. So the three of us are sort of playing host tonight. And then we have a few special guests. When we meet in person, I should say, when we meet in person, it's an open discussion. There's, anywhere from 10 to 50 people, but it's easy to have an open discussion. What we're learning doing the Zoom is that it's hard to have an open discussion in the Zoom format. So we're moving to more of a talk show format. So so we have some hosts, we have some guests. So the first portion of tonight will be mostly the hosts and panelists talking, and then we'll open it up to audience questions. If you have something urgent along the way, just feel free to post it in the chat. So our special guests tonight, we'll have them introduce themselves in more detail, but we have Allison Bales, Ben Bogie, Scott Gibson, Nikki Krueger, and Brian Pontolilo. I could say stuff about each of them, but they will be able to do it more efficiently. So I will turn it over to Emily.
Hey guys, Emily. So BS and Beer, so we'll start out with the beer. Hopefully you all brought your good beer tonight, brought to you by Goose Island IPA. Not drinking something local tonight, but the options were Goose Island or Michelob Ultra. So anyway, let's...
You made the right decision.
I did make the right decision. So that's what happens when your husband's the only one that goes to the grocery store. Ground rules, couple of ground rules. When you came into the meeting, you automatically got muted. So for the first half an hour or so, just keep yourself muted if you can, so that the speakers and everybody, that there's no interference there. Unless you're called on, if somebody calls your name, feel free to unmute yourself, join in the discussion. Use the chat box to either answer questions or ask questions. So throughout the course of the discussion, there'll be a bunch of stuff that comes up. The chat box is usually pretty lively. If you got here through somebody else's link, feel free to join our mailing list. We'll send out the chat conversation afterwards. So people in the past couple of meetings have shared a lot of great information in the chat box. So we'll forward that on afterwards and ask questions. Currently, we are doing this in gallery view. I'm not sure what it automatically does on your screen, but you can change it to gallery view or speaker view. If it's in gallery view, it looks like Hollywood Squares. There should be like 20 to 30 people on your screen. If it's in speaker view, you're probably only seeing me, and you'll see whoever is making the most noise will pop up on your screen. If you have questions about how to change that, send me a private message in the chat box and I will handle it. I'm sort of doing tech tonight, so if you need help with that, just let me know. Also, I wanted to say thank you for Green Building Advisor. They're going to help us carry this along and meet more people along the way with BS and Beer. So reaching out and sharing content and building science, and while we're all kind of stuck at home, sharing and supporting each other. So thank you for Green Building Advisor. The video conversation will be available in the future on greenbuildingadvisor.com. I'm not sure exactly where it will live, but on their website, and also probably on the Pretty Good House YouTube channel. So if you're a YouTube subscriber, it will also be located there. And I will turn it over to Travis to introduce himself and what he's up to.
Hello, I'm Travis Brungardt. As mentioned, I'm out of Kansas City. Actually a small suburb of Kansas City, but it doesn't really matter. Kansas City. I'm drinking a Free State Guavatas, which you can't really see because of my fancy green screen. There we go.
There it is.
Yeah. So local to Kansas City is Lawrence, where the University of Kansas is, and they have a fantastic brewery there called the Free State Brewery, and I'm drinking a Guavatas sour, which I would highly recommend. I'm a residential remodeler and builder here in the area, and a building science enthusiast. As Mike said, I, with a couple of friends, one who is my business partner and another who is not, founded the Kansas City BS and Beer, and have gotten really involved with people like yourselves, much to my benefit. So I will mention briefly that we have some swag to give away later. So after the panel discussion, we're going to do a little pop quiz. So pay attention, you don't want to miss anything, because otherwise you won't be able to win this cool stuff. From what I understand, Nikki has 2 Yeti travel mugs and 6 Yeti wine cups. So pretty high value items there. Allison has offered a signed copy of his forthcoming book, which is so hot off the presses, it's not even available yet. So you're really getting into the ground floor if you win that. From what I understand, Ben Bogie has a stack of 10 Pretty Good House stickers, and I'm offering up some of our local BS and Beer Group swag, which is basically just coasters and stickers. So anyway, cool stuff for all to enjoy if you can answer the questions correctly in the quiz. I guess at this time, since everyone's drinking beer and talking building science, we should raise a glass to the good health and good fortune of all of us to be able to share a pint together and some good ideas. Prosit. I guess after a drink, maybe our guests could introduce themselves. Allison, would you like to start?
Sure.
Could I just jump in for a second? It looks like, okay, yes, somebody was screen sharing. So
I figured it out.
You did? Okay, cool. Take it away, Allison. Oh, you're on mute. Oh, you're on mute, Allison.
Oh.
In the lower left, there's an icon with a microphone.
Oh, I see. Okay, okay.
There you go, brother.
Got it. All right. My name's Allison, and I am not drinking a beer. I have a sidecar here. It's a cocktail made with lemon juice, cognac, and Cointreau. And it's one of my favorite summer cocktails. And it's getting warmer here, so I've started making those lately. Anyway, introduction. Well, let's see. My background is physics, as many of you know. And if you know me, you probably know me either through Green Building Advisor or the Energy Vanguard blog, which is my company, Energy Vanguard. And I've been writing for Green Building Advisor for almost as long as I've been writing the Energy Vanguard blog, which is 10 years now. I started at GBA, I think 2011. And so been doing a lot there. I've built a house once, almost 20 years ago, out of structural insulated panels. It was very airtight. I had never even seen or done a blower door test, but it came in at 1.4 ACH 50. So I was proud of that. After I learned about blower door testing and did the test on that, but it came so tight, got so tight. It was so tight. And I've also done contracting. I was a home performance contractor for a few years and worked at South Base Energy Institute. Some of you may have heard of that. It's a nonprofit in Atlanta, started in the 70s as a solar organization. now stuff. And for 12 years, I've run Energy Vanguard, and we do the blog. We do quality assurance for home energy, well, formerly raters, but we do some other stuff with that now, and consulting, HVAC design, and a bunch of different things. So that's me.
And I guess we could move on and go to Ben.
Oh, can I say one more thing?
Oh, please do.
I forgot to mention, yes, I'm giving away a copy of my book, which I'm writing at the moment. And the book, I hope it'll come out later this year. I'm doing a pre-sales campaign right now on publishizer.com, and you can pre-order copies of the book. A bunch of you here already have pre-ordered copies. So if you have not done that yet, you can go to publishizer.com. It's easy to find my campaign. The house needs to breathe, or does the title of the book and the campaign. So it's easy to find.
Okay, so tonight I'm drinking, depending on your definition of local, a famous, infamous heady topper. Quite delicious. Working my way through my beer stash here in quarantine and getting into bigger and bigger bottles as the days go by. So I'm a second generation high performance builder. My father was doing stuff like traveling to Saskatchewan in the late 70s to look at the Saskatchewan Resource Conservation House, and I've been brought up with building science in my blood and beaten into me. I am now a production manager for Kolbert Building here in Portland, Maine, and just an all-around building geek. I love diving into all the nooks and crannies and seeing what I can figure out, because it keeps me interested in what I do on a daily basis, because it doesn't take too long to figure out how to cut a board and nail it up, so you got to do something to keep yourself passionate. If anybody needs help finding Allison's book, Publishizer, you can go find me on Instagram under my name, Ben Bogie, and scroll down a little bit, and there was a post leading you to Allison's book campaign, and I suggest you go and do it, because Allison is a brilliant individual, and I'm looking forward to reading it. So that's what I've got to add.
Thank you.
All right. How about we move on to Scott Gibson?
Hi there. Some of you I've met and know a little bit. I'm a reporter, a freelance reporter. I live in Portland, Maine. I've been working for the Taunton Press for about 25 or more years, and started with GBA pretty much at its inception. And I do reporting for both the magazine and for GBA at this point. So, you know, my focus obviously is what you guys are interested in, building, efficient building, green building, and that kind of thing. So that's about it.
Nice. Nice to meet you, Scott.
You.
And how about Nikki? Where's Nikki at?
I'm right up here.
Hello.
Hello.
Welcome.
My name's Nikki Krueger, and I work for Therma-Stor. I've been in the indoor air quality industry for about 20 years. Last 12 years, I've been focusing mostly on moisture control issues, controlling moisture in homes and buildings, and ventilation. We are drinking, I am drinking, we are drinking margarita, homemade margarita with homemade habanero tequila in these nice mugs. And this one will be one of the ones I owe a wash and send out to somebody. I'm just kidding. I'm just kidding. Especially right now, that's no joke. So I'm just kidding.
That's awesome. All right. So I guess we also have Brian Pontolilo. Brian, where are you at?
Yeah, I'm here.
Hello.
Hey, everyone. I am Brian Pontolilo. I'm currently the editor at Green Building Advisor. I've been at the Taunton Press with Fine Homebuilding and GBA on and off for, geez, I guess over 15 years now, not quite 20, somewhere in that range. And I've worked on building projects over the years on and off as well. So I'm certainly in over my head a little bit tonight, given the topic of discussion, indoor air quality. But I kind of have developed a pretty wide breadth as a generalist in building and green building. And I get more and more intrigued the longer I keep paying attention to this stuff, the more interested I get in the building science aspects of it. So we're really glad to be here, really excited to be partnering with this crew, and honored actually to be part of the team, I guess.
Awesome.
Thanks, Brian.
Thanks.
Yeah.
Well, I guess at this time, should we go ahead and kick things off with some questions for the panel?
Well, just first, Travis, just because a lot of people are still new to Zoom, let's just make sure everybody understands how the chat box works. So for anybody who doesn't know, at the bottom of your screen, probably depending on your device, there should be a button that has a chat icon, and that will open up a sort of like a text box, probably on the right side of your screen. If you're on an iPad, it'll drop down from the top. That's sort of for queuing up questions and for banter and whatnot. So just, and that's where we'll be queuing up questions for the last half of the show. So just in case anybody missed that. Any other announcements, or should we jump into the conversation?
I think we're good. If you're good, Allison's up. Let's ask Allison. Could you, Dr. Bales, excuse me, could you define for us what is indoor air quality? How do we create that good indoor air quality, and then how would you measure that to know if it was good?
Oh, that's a good question. Gosh. So
it's Mike's question, so don't give me that credit. Thanks, Mike.
So indoor air quality I don't have a concise definition. It's a very broad thing, because there's so many different things that can affect it. The moisture levels in the home. Water vapor itself is not an indoor air pollutant, but it can do things that create indoor air pollutants, and it can create indoor environmental quality, which indoor air quality is part of the broader topic of indoor environmental quality. So I would say good indoor air quality is a state of the indoor air where you're not having, first of all, you're not having noticeable indoor air quality problems. And odor is one of the first things that it gives you an idea of that. But you're also not having unnoticeable indoor air quality problems, and things that you would have to measure, like radon or carbon monoxide or carbon dioxide, volatile organic compounds, VOCs. There's a whole lot of things that can go into the air, and they get there a lot of different ways. And I guess that's kind of a mushy definition, but that's where I would say it goes.
It's a good enough way to start us off.
Yeah.
Would anyone like to chime in on what's a good way to create good indoor air quality?
Well, I think I'll just chime in with what I would define as indoor air quality would be an environment indoors that contribute to the health of the occupants. So my indoor air quality needs might be different than somebody else's indoor air quality needs based on, if they have respiratory issues or allergies or something like that. But I think overall, there's safe parameters that we need to try to keep homes in to create the most effective, healthy environments. And then from there, depending on who's living in that space or working in that space, we might have to take extra steps based on their health. So I think if we have healthy people in buildings, we've ultimately created healthy indoor air quality.
Ben, anything to add on your end? What do you think about?
I think one of the biggest things for me is it's tough to define what is the healthy indoor environment. The research is right now still so young and in its infancy that it's tough for us to pin numbers on what defines a healthy indoor air quality. And the other tough part about the situation is how do we actually measure it? The sensors, thankfully, are starting to become more widely available and affordable, but for the longest time, they've been incredibly expensive lab-based tools. We're seeing a lot of user-grade tools come onto the market. How much we can trust them is questionable. I know Scott just had a piece on GBA the other day about a couple of them. But I guess what I'm trying to say is the whole conversation here about indoor air quality is we're really defining it right now, and we're really just in the early phases of really starting to research and figure out what we have to be paying attention to. So it's a tough subject.
Yeah. Right.
Well, can I jump in with the? It's interesting that the EPA, I guess it's the EPA that sets limits or recommended limits on radon, but when it comes to CO2, VOCs, and tiny particulate matter, the EPA doesn't have any established recommendations for what's healthy and what isn't.
Scott, can you, just in case anybody, or for anybody who's not as in the trenches as we are, can you just briefly explain what VOCs are?
Oh, sure. VOC stands for volatile organic, help me out there.
Compounds.
Compounds.
Right, okay. So these are things, they're aromatics that can be produced by like paint, all kinds of things that we would normally associate with like a chemical odor. But they're also things like orange peels. There's really a really long list of what a VOC is. Some of them are bad for you and some of them aren't. Particulates, PM, the EPA and others are interested in the really tiny stuff, the 2.5 microns across and less, because they go so deeply into your lungs. So PM 2.5 is what the industry calls those little tiny things. Those are, you know, some of the big deals.
Oh, sounds good. And Brian, you had an article last fall on Green Building Advisor that was basically all about VOCs, as I recall. Did we miss anything, or all about indoor air quality? Is there anything that we're missing in the?
Well, I looked at indoor air quality through the, you know, with the focus on VOCs, and what in some ways what I found echoes what Nikki said before, that in mentioning that, you know, with all these different, there's many different types of VOCs, like Scott said, and with all the different types of VOCs, there's all different types of people with different sensitivities. And so something that may not bother one home occupant may actually cause, you know, quite significant health issues with someone else. There's not, and to Ben's point, there's not a whole lot of research that you'll find, at least there wasn't a whole lot of research that I found when I was looking to sources that we might commonly look to, sources in the home building world, the building science world. But when I started to look at academic sources using a couple of sites like Google Scholar, and there's Academia, I think is another one, and I did find quite a large body of academic papers with pretty significant evidence pointing towards certain VOCs and certain health issues. A whole bunch of studies on asthma and eczema in children who have been exposed to high levels of VOCs in their homes. And it was enough to, when I did that research, it was enough to make me think that, or make me hope that we can get to a place where we can start to monitor VOC levels in homes, not only more accurately than we can do it now, but more specifically, because as Scott mentioned, there's VOCs that are not a, you know, a health issue for anyone, and then there are VOCs, you know, like formaldehyde, for example, which is a health risk for everyone. And you're not going to know whether formaldehyde is having a health effect. It's a carcinogen, so that's sort of a slow burn, right? You're not going to know that you have a formaldehyde source in your house and you're breathing those VOCs on a regular basis. You're not going to know right away that you don't feel good. That's something that that takes a while for you to sort of run into the up against the actual health issues with. So doing that research at least kind of made me think that this is more important topic than I knew it was. And also I found that there are sort of no house is going to be chemical free likely. I talked to an expert who does, who does real testing, laboratory testing on homes. And he says he's never walked into a new house that he didn't find the air full of chemicals in. in his whole career. But there are some kind of straightforward things that we can do. You know, we can choose not to bring known problematic things into our house any more than we need to. We can choose to store materials, you know, outside of the conditioned envelope of the home, paints and things that we know, you know, can be problematic. So there are a whole bunch of steps that we can take. And then of course, and this is where, you know, I can only mention it, I can't speak to specifics too well, but of course, proper ventilation, you know, and filtration and keeping the air going out and coming in at the right rates. That's the big one.
Yeah, that's it. I mean, yeah. So is it, I mean, I think, you know, most of us here interested in high performance building are doing balanced ventilation now. Wasn't long ago but the vast majority of homes still don't have balanced ventilation or even ventilation at all. How important is mechanical ventilation? How important is balanced ventilation in helping create good indoor air quality? And that's for anybody who wants, or any of the guests who want to jump in on that.
I'll jump in on that first, if you don't mind. Brian mentioned the most important thing first just a minute ago, and that is source control. If you want good indoor air quality, you've got to control what comes into the house, because VOCs are one thing, and all kinds of materials have stuff that comes out of them. Paints, although paints now are much, much better than they were 10, 20 years ago. And OSB and spray foam, sealants, just about everything you put in the house has some tendency to create VOCs that go into the air. So pay close attention to the materials you bring into the house. And there's an old quote from the 19th century, some German guy, I think, who said, if you want to improve the air quality in the house, don't bother with filtration and ventilation until you've removed the pile of manure that's sitting in the living room. If you've got a pile of manure sitting there, get that out of the house first. You know, source control is number one, and then you start looking at filtration and ventilation, and those things also are very important.
So I'd just like to jump in, kind of just back to Brian's point a little bit on VOCs, and from the work and what I've learned the last several years is a lot of times, absolutely source control is number one. But also with that is controlling the relative humidity also helps slow down the off-gassing, which they know, especially for like formaldehyde and stuff, that products will off-gas slower when we keep the relative humidity down below like 60%, if not a little lower, and that will really slow it down quite a bit. So, and ventilation is huge. We really need, especially with these tighter high performance homes that we're building, we need to bring in fresh air, but we also need to make sure that we're bringing it in from the right places. We're filtering it and delivering it to the rooms where people are spending their time.
I can chime in with something here as we're on this train of talking about VOCs. So VOCs are known to be problem causers in a lot of ways. So we went and kind of outlawed VOCs. So everything's now low VOCs, all these paints, all our products and everything that we're using in the home. And the problem that we're running into now is those VOCs have been replaced by what are called SVOCs, semi-volatile organic compounds. And what we're discovering now is we got rid of the VOCs, great, but we're finding that these SVOCs are actually longer lasting and potentially more dangerous, because VOCs are released rather rapidly. You know, you open up a thing of paint thinner, it stinks, and you close it and it kind of dissipates rather rapidly. What SVOCs do is they release very slowly and over a long period of time. So we might not have this large VOC load in the house when we're using products or at the time of construction, but we've used all these products that are now releasing over a long period of time and potentially causing real serious health risks because they're titrating in people's bodies and building up. Another part of this equation is this isn't exactly just the VOCs or the chemicals that we bring into the house that are the concern. It's the interaction that they have with other items inside of the house. So you bring in something like bleach into the house, which we know is a risk, and you release that chlorine gas into the house, and now that chlorine gas starts reacting with everything else around you, with the upholstery and the paint and the stir fry that you just made on the stove, and it starts creating new chemical compounds inside of the house. So I don't know if I'm really defining a clear line here in the sand for these things, but basically what it's getting at is back to what I said at the beginning is we really don't know yet. And where this ties back, or the point I'm trying to make, is that it really is about source control, like Nikki's saying and Allison's saying. We have to get the bad air out from where we're creating it, mostly in bathrooms and in kitchens, and we need to supply fresh, clean air to where we're spending most of our times, usually in our bedrooms. So you can have these big ERV systems, ventilation systems that are supplying air all throughout the house, but if you're not managing the pollutants at their source or keeping them outside of the envelope, then you're really not effectively controlling the air quality inside of the house.
Yeah, let me say one more thing about VOCs, because VOCs are the huge wild card in indoor air quality, because there are so many different ones out there. There are thousands of different volatile organic compounds that could end up in the air in your house, that end up in your lungs. On the other hand, we look at carbon monoxide as a single thing. We look at radon as a single thing. Those single things are easy to study and easy to get data on and easy to measure in your house. But which VOCs are you going to measure? You have to know what things you put in the house, what the house is built out of. So that's a difficult question when you talk about VOCs. It's a big, big Pandora's box that we opened with that one.
How does, since everybody now is dealing with, or almost everybody now is dealing in one way or another with quarantining due to the COVID-19 virus, how does that impact indoor air quality? Basically, if we're spending more time in our house, in our homes, is that generally affecting indoor air quality? Is it not affecting it? Is there a way to, instead of scaring people, is there an easy way to mitigate poor indoor air quality? How about Brian or Scott? We haven't heard from you guys in a few minutes.
I really wouldn't know how to answer that question. The article that I worked on and researched was about these pretty budget level air quality monitors, but they had nothing to do with, the kind of virus related things that we're, all dealing with at this point. I don't know. It would take a more of a specialist than me to figure out how this COVID-19 thing would be affecting indoor air quality, but ignore the virus itself and just the fact that we're all spending a lot more time in our homes and apartments than we were, 2 months ago. Is it a matter of just opening a window? Is there a specific device that you found that is sort of the best, a good all-in-one measuring device that will let you know when there's a problem? Is carbon monoxide or carbon dioxide, are those the ones you want to primarily be looking out for? Well, to Allison's point, there's so many VOCs that I don't know, really these monitors are not that helpful in that regard. Mm-hmm. They're not necessarily tuned to anything in particular. So you see a number on the screen, you don't know what that means. But my limited experience with these things, with the carbon dioxide, was a really interesting phenomenon. And you could see that level go up the longer you stayed in a room without opening a window, or you just worked in a little office all day, like I do a lot of the days. That really goes up in the afternoon. You go, well, maybe that's why I'm so sleepy. So yeah, I think there's some lessons there, CO2 for sure.
Yeah.
I think there's a lot of activities that, that we if we really are concerned, and again, it's going to depend on each of our sensitivities, but if we're really concerned, there's a lot of activities that we might, when we're home a lot, like a time like now, and if our house doesn't have what we consider to be adequate ventilation, if we can't open a window, maybe because of the time of the year, whatever, then it's important to think about our activities. Something like burning a candle or burning incense are two things that just jump to mind for me, like that are going to affect your indoor air quality. I mean, those burning a scented candle, for example, or a stick of incense, you're putting some things into the air that maybe you don't want to be, maybe you don't want to be breathing that much of. I burn candles and I burn incense a little bit, but that when you're home a lot, maybe it gets, your when you're home a lot in a situation like this, all of a sudden, unexpectedly, not used to being home all the time, we might start to change our habits in ways that we're not aware of. So to just be aware of what our own activity might be creating, and that's just to get. I mean, I guess that's always true, but that's just to get to your point, Mike, about the fact that we're all kind of in a situation where we're inside in our homes a lot now.
Yeah.
I did a webinar today and we talked about, basically making our homes healthy right now because there's so many people home at one time for extended periods. And I think one of the things that kind of triggered it for me is I find myself cleaning a lot more than I used to because I have the time. Plus I'm a little bit worried overall about, what am I bringing in, or what is he bringing in over here. So, all the chemicals that are in our cleaning products as well are probably having more of an effect on our indoor environment right now than they typically do. Plus people put off a lot of moisture. So you got to think about that, and CO2 levels. And I see a lot of people saying, well, open up the window. Well, here in Virginia, everything's covered in yellow pollen right now. So depending on if you have outdoor allergies or not, opening a window isn't necessarily the best thing for you to do. Depending on what your outside situation is, if you live next to a really busy highway, we talk about PM, the PM 2.5, that's not just your lungs. Those smaller particles are getting into our bloodstreams. So when we break stuff down, it isn't so easy as just open a window and all these other things. It all depends on where we live and what's going on in our homes.
Well, let me address the elephant in the room. It's kind of been danced around, but nobody's actually talked about it. Brian came close talking about burning candles. But one of the biggest activities that's probably happening more in everybody's home now that we're all spending so much time here and that we can't go to restaurants is cooking. And cooking has an enormous impact on indoor air quality in the home because if you're cooking on the stove, and a lot of people don't use the range hood, so they're cooking on the stove, and if they've got a gas oven, especially, that's bad because you're getting a lot of bad stuff. Even with an electric oven or range, you're getting the ultrafine particles, and cooking puts a lot of PM 2.5, particulate matter 2.5 microns or smaller, which is the bad kind of particulate stuff. And that's one of the worst parts of the indoor air quality. And that's something that we can measure. And that's something that we can filter out too with a good HVAC system and proper filtration.
Oh, that's good. I had a bunch of other questions I wanted to get input on, but we're well over the halfway point. So I want to switch gears now and do a quick pop quiz. This is the first person to answer this correctly in the chat box will win a copy of Allison's forthcoming book. So we're picking the question that we went over with him earlier. One way to improve your indoor air quality is with balanced ventilation, either HRVs or ERVs. You may know ERV as an energy recovery ventilator. What is another more technically accurate term for the E in ERV? It looks like Rick Evans got it. Rick, you want a copy, and Kyle almost got it. Sorry, Kyle. All right, congratulations. Let's move on to answer some questions from the rest of the group. I think if Emily, I think, has been monitoring chats to some degree.
I have been, and I'm actually going to start from the bottom because one of the questions that just came up was, what is a good indoor air quality monitor? What did it say?
Oh, well, and first, Emily, did we say early on, did Travis mention that that if we pick your question to answer, then you'll get one of the swag gifts, either one of Nikki's Yeti mugs, or one of the stickers from Ben, or sticker and coaster from Travis?
He didn't mention that, I don't think.
Okay.
So if we pick your question, which I've been monitoring the questions on here, you get a swag. Do we let them pick their swag, or do we
I think that's going to get complicated. Let's just, you'll get one of them, and in order to get it, you have to, it's hard for us to keep track of
yeah,
everything.
right.
So just either just message us one way or another. I'll put my email in here. You can just email me directly.
Yeah, so DV Salco, because of course not all of your names come up and I don't know everybody. So your question was, what's a decent monitor to buy for CO2, humidity, et cetera, and from where? I think that was going off of finishing the rest of that chat that we were just having about talking about indoor air quality, VOCs, monitoring, et cetera. Does anyone from the panel have a suggestion? There were a bunch of suggestions that popped around possibly last week, but anyone want to chime in there?
We've used a Hvac, which is a pretty widely available air quality monitor in some projects to kind of see what's going on. They're about $200 a pop, and apparently they're releasing an updated version. It's not the greatest, but it gives you some sort of readout to look at. And like Scott said before, we don't, it picks up some things, it doesn't. At least it gives you something to look at to correlate behaviors inside of the house to an actual number.
I would just say with any of the low-cost monitors, and when we're talking about $100 to $200 for an indoor air quality monitor, that's low cost, because the research grade monitors can cost many thousands of dollars. But another one that the guys at Lawrence Berkeley Lab like is the Ultra-Aire one. I don't have one of those yet, but I'm planning to get one.
I have my passive house friend in New York liked the Yoo-Hoo, so I have a Yoo-Hoo monitor that I really like. UHOO.
I would like to say that probably the best list that I know of that rated these things comes from the Air Quality Board in Southern California, which has an ongoing test program, and they have something like 25 monitors for $300 or less. But the thing is that these things they're not specifically tuned for where you live. They're not calibrated for the kind of pollutants that are going to be in your air. And the results, the monitoring that these things do is, I think it's a mistake to look at these things as accurately measuring the real level of pollutants. They'll give you a baseline that will show you what increases the CO2 or the VOCs in your house. They'll show you when they go up as related to an activity you may be involved in. But in regards to getting a really accurate readout of what's going on in your house, I don't think that's what these things are for. They're just not that accurate.
Yeah, don't compare the numbers you get from those to any kind of standard or recommendation.
Right. That's my take on it as well.
Who wants to pick the next question?
Do you want to grab one, Travis?
Oh boy, if I was on
Here,
it,
Travis, I will copy them all to you.
I saw one that was interesting to me, since I'm slow at reading the chat box. It was questioning when it's appropriate, if at all, to turn off your HRV during the hot, humid summer. I saw that just a minute ago. Oh, and of course, now you've supplied everything to me, Emily. You're amazing.
Ah, yes, and now to Mike as well. So.
Well, look at that. Man, you are organized.
So I think with ventilation, you ventilate when people are home. So you put in the right systems to be able to handle those conditions so you can provide good indoor air quality when people are in the house. And I know that, we want to lock out ventilation when it gets too hot or when it gets too cold or when it gets too humid. But the reality is, if you're in Louisiana, those conditions can last a long time. And obviously other parts of the country. So I would not recommend ever turning off the ventilation because of conditions outside. First of all, ventilation is going to cost you money. Just like Dr. Joe says that, it's going to cost you money to keep dry. So those are the two things that are going to cost you money that really contribute to indoor air quality. And you just put in the right systems to hopefully be able to to handle those conditions.
That's a good answer. You want me to pick another question? We can go with how important is periodic HVAC duct cleaning regarding best practices? Anyone want to jump on that?
I'll take a stab at that. Yeah, so duct cleaning. So the duct cleaning companies, now I don't know this for sure, but I've heard about some duct cleaning companies that will go in and they'll go down in the basement and they'll get their hammers and they'll just start banging on the ducts and make a bunch of noise. And then an hour later they come up and they give you the bill and they never did anything. I think that's probably rare, but the other problem I have with duct cleaning the main problem I have with duct cleaning companies is they have their hammer and everything looks like a nail. You know, if there's a duct, they want to clean it, and they don't always look. I mean, they rarely look at why these ducts are so dirty. Is there a lot of duct leakage? Is it a poor design? Should they change where the return vent is? There's a lot of you're looking at. So duct cleaning by itself is sometimes necessary, I think. If you've got an old duct system and you don't want to replace the duct system with one that's going to work properly with this new system that you can put in, which you probably should do. You should probably just gut the whole thing and put a whole new system in. If you don't want to do that because that's expensive, then duct cleaning can work, but you've got to also, you know, look at the whole system. You know, we preach the house as a system all the time, right? So you gotta look at, you know, how much duct leakage is there? Is there a problem with the vents that's causing ducts to get extra dirty? Is there filter bypass that's causing problems? So there's a lot of other things that they should be looking at as well. Duct cleaning by itself is not a panacea to anything.
In that same vein, there's been some research done showing that the air quality and level of pollutants inside the house actually gets markedly worse after duct cleaning is done, because you have all this stuff that settles in the ducts and it's kind of, you know, stagnant there and holds in place, and it's not really getting stirred up, which is why it's in there. So what's happening is they're going in and they're stirring all this stuff up and getting some of it out, but it's now being aerosolized, to use a common word nowadays, and getting brought back into the airstream of the house. A good way to mitigate having to deal with that is to put a filtered return in on your HVAC system and just filter it before it even gets into the duct system.
Yeah, and a comment I like is if your air is clean, then your ducts shouldn't be very dirty. And Russell Chapman says he likes clean ducts anyway. DUCKS.
And geese.
And geese. Is there I think Elizabeth has asked a couple of times, or in a couple of ways, I'll paraphrase it maybe for broader impact. Is there, if you're doing a passive house, what is different in a passive house about ventilation and indoor air quality than in a conventional house? Like, you know, you can't really direct vent, so you have to do recirculating, as far as I know, as far as I have seen. But a tenant of passive house is better indoor air quality. So how do you bridge that gap? I know. Allison, are you still on the FIAS board? I know you were at one point.
Yes, I am.
Yeah. So how does passive house see ventilation or see indoor air quality versus not passive house?
Well, I mean, it's as with any high performance home or a high performance home program, indoor air quality is really important. And in passive house, all of them, not all of them, most projects have the recirculating range hood, and I'm not a big fan of those. You can do passive house without those. The more extreme the climate, like, you know, up in Maine or Minnesota or something, it might be more difficult to use a range hood that vents to the outdoors because of the energy hit that you take for that. But it is possible to do passive house with a range hood that vents to the outdoors. And if you can do that, if you're doing passive house and you can do that, I would recommend that. that's one aspect of it. And otherwise, I mean, you know, have a good balanced ventilation system, make sure it's commissioned properly, that you change the filters and maintain it and all the normal stuff.
Yeah.
Can I ask a question of Allison? You mentioned these recirculating range hoods. Do they actually work?
Well, you know, I heard John Straub several years ago talk about recirculating range hoods, and he says, "Would you want a recirculating toilet? The stuff just goes around and around, and it never leaves." That's not actually a completely accurate comparison, but the with the kitchen ventilation, I am a big fan of range hoods that vent to the outdoors. There's a professor at University of Colorado in Boulder, Shelley Miller, who's done some research on that, and she's found that the recirculating range hoods just don't perform as well for indoor air quality as the ones that vent to the outdoors.
So something really interesting in the QAP for North Carolina for their multifamily affordable housing, you had the option to put in a vented kitchen hood or a dehumidifier, which doesn't make any sense. You use a kitchen hood for a very different reason than you do for a dehumidifier. So those were the two options. I think they just recently changed it, but they were only looking at if somebody was boiling water on the stove, the humidity issue, but the VOCs from cooking are really the key of why you want a kitchen hood. So
and PM 2.5.
And that's exactly it. Yep.
I saw an interesting thing come up in the questions in the chat box, and maybe it's prevalent now as we're dealing with this virus thing, but what happens with, what did it say? What do you do when the outdoor air quality is also poor? How do we manage indoor air quality mechanically if the location doesn't harbor good exterior air quality? Are there options available?
Yeah, that's a really good question, because if you're doing a lot of ventilation to improve your indoor air quality and your house is right next to a very busy freeway, then you're problems with that. In cases like that, you probably want to watch the cycles of the traffic on that freeway and ventilate less or not at all during rush hour, and do most of your ventilation when there's not much traffic out there, and probably make sure that you have better filtration and really good source control.
And something else, and this is kind of a really niche option, is if you do get yourself into a situation where you have like a paper plant next door and you have somebody with, chronic breathing issues, there are options and things that are called sorbent filters that will actually remove targeted chemicals or pollutants from the incoming airstream that can't be taken out by a traditional, filter media. So there are other things out there. These are generally just focused towards larger commercial applications. I have seen some of them getting filtered down into, the residential scale market.
Excellent. This is a good time. We're just about at the 6-minute mark before 7 o'clock. We are going to officially close things at 7, but we'll keep the doors open for a few minutes after if anybody has a few straggling questions. But for anybody who wants to go at 7, we'll do an official close down then. What's another audience question? I haven't been paying close attention. Does Emily or Travis, do you guys have one ready to go?
Here could be the point at which we talk about relative humidity and dew point. We talked about cooking and dehumidifiers. And so there's always the question of what is good relative humidity to have indoors, summer and winter. There was a bunch of things in the chat box. Somebody said 75 in summer and somebody else said, oh my. Who wants to jump on the relative humidity chat? And I will bring up this lovely chart that I think Allison shared earlier today. Can you all see that?
Yeah. So I think that was me saying 75 degrees.
Oh, not 75 RH.
Not RH. No. But when we look at this chart, we get a lot of calls from people wanting to keep their relative humidity, or you know, like 50 in the wintertime in Wisconsin, and not realizing that, again, when we hear these recommended relative humidities from credible third-party organizations, they're never in correlation with what the temperature should be. So, right, it has to be relative to a temperature. 30 RH in a cold climate in the wintertime is a good goal. It'll be hard to do that in a leaky house. And then not going above, I mean, ideally, if you look at this chart, 50 in the summertime or in the humid months, spring, summer, fall, 50 is where we really want to be on this chart for health reasons. So I would say that obviously dew point, if you're in the industry, dew point is really important to understand, but homeowners don't understand relative humidity, and we're never going to get them anytime close to dew point. And dew point is really going to be the indicator of how much moisture is in the air outside. And it's going to affect our indoor environments as well.
I don't know if this is a question for Ben. I've seen a lot of, we have a pretty humid summer that lasts 3 to 5 months here in Kansas City. We run into a lot of our clients' homes where the woodwork is moving so much, over 50%, really anything over about 45, I see movement. So I worry about, I mean, obviously health takes the top priority, but can we talk about what else it's doing to your house when we get up around those higher marks? I know it's not an indoor air quality discussion in terms of health, but it's definitely important to the performance of the house in terms of aesthetics and other, you know, no tripping hazards if my floor is cupping, you know?
That's a tough one. Because you have to kind of find a balance between, you know, aesthetic goals of what you want or how you want the house to perform if you have a lot of woodwork in the house versus, you know, comfort goals and health goals of the house. I've seen something pop up in the chats right here. Somebody asked about where we like to supply makeup air for ranges, and I said that I like to bring it in underneath, directly underneath the range or in the toe kicks either side. And the rebuttal is people, they don't do that because people feel a cold draft across their feet. To me, I understand that people don't like a cold draft across their feet, but I'd rather have something contributing to a safe and healthy environment over an aesthetically pleasing or comfortable environment.
Well, if you can't take the cold, stay out of the kitchen.
Exactly. It's the truth. So we have to kind of, you know, look at, you know, it's weighing risk and weighing your priorities with all of these things. And there is, you know, no panacea answer to all of this, you know, so it's really case dependent. Every house is, you know, a different case.
Excellent. Well, we're just about at 7 o'clock, so I'd like to just give a huge thanks to our guests tonight for taking the time to share their expertise, and thank you to my co-hosts for taking the time and about 1,000 emails to prepare for tonight's discussion, and to the audience, everybody who's joined in. I know this is an hour out of your day. Hopefully you got something out of it, and hopefully you come back next week and share among your friends and coworkers. So we'll do an official good night and go on to the next question.
I want to make an announcement too, for those of you who are on this and are not part of the email list and want the links in the chat box. Go to Mike. Where's where does it live?
For the mailing list.
Yes.
Yeah, so there's a MailChimp account. The easiest way to get there will be to see what would be the easiest way. Go to BS and Beer Me on or just go to my Instagram account. Michael Maines at Michael Maines is my Instagram account. So MICH. Here, I'll put it in the chat box.
Yeah, pop it into the chat box and your email address in case people aren't on Instagram. If you want to get added to the email list for future invites to hear I'm sure we'll do another survey as far as what times work. I know there are a bunch of people who joined us from other time zones. So if 6 o'clock Eastern Standard Time doesn't work, we'll ask about that. But we'll also send out the chat box with all the great links that have gone up in here. So if you're not on the mailing list already, please join the mailing list. If you want to know more about Allison's book, Allison and I have recorded a podcast this week, so that'll be up tomorrow, Energy and Efficiency with Emily. So more on Allison's book. There will be links to the publishizer on that as well. So if you want to pre-order his book, we will do that. You can also, if you're not an Apple user, you can find it on my website. It's in the chat link. So if you're on our website, you'll get it from the chat link or scroll back up. I think those were the only announcements that I had. Travis, did you have any other announcements you wanted to throw out there?
Not really. I mean, if people are following on Instagram, there's still the Sweet 16 going on. All the submittals are in, but voting starts after Selection Sunday. So if you're like Ben and you have a submittal in there and you want to defend it, since I did a terrible job of that earlier in the week, you should definitely get in there and make some comments. Voting, I think the Selection Sunday will happen with Joe and Joe, and then we'll have everyone seated and the voting for the first round can begin. And if you want to get involved in that and you're not on Instagram, you can go to BS and Beer KC.org, and there's actually some other stuff going on there as well later in the year. So check it out, bsandbeerkc.org. Thanks.
Who's got a question? Panel or audience? Anybody? Throw something out there. The official swag is gone, so this is just a free for all.
A free for all.
How many do we still have 79 people here, so I guess maybe that's dangerous, but let's
uh-oh, yeah, free for all. The chat box is going crazy, Mike. What'd you do?
Yeah. Alex Degagne is here with he's the sales rep for a Untitled Pentacare V12, I believe. They have a cool device. It's sort of an ERV, sort of an HRV, sort of a dehumidifier, sort of does a bunch of things for low load homes.
Up to 1,000 square feet, I think, right?
Are you there, Alex?
Yeah, good evening.
Dinner time.
Very interesting discussion. Just finished my meal. Everybody, it's cool to see all those IAQ colleagues. Yeah, hi Allison, Michael,
Hey.
Nikki, and all the rest. Emily that I don't have the chance to know, and all the other. I saw Chris Corson. Hello, Chris. And other great people, Elizabeth DeSalvo also. Hi, Elizabeth. Yeah, thanks, Mike. I didn't know that you would introduce what we do, and in a few seconds, for the one who don't know what we do, we are a manufacturer located in Hvac, and we do a machine, what it's called a Pentacare. It's a heat pump combined with an HRV doing active heat recovery. So it's a machine taking care of 5 things, providing fresh air, heating, cooling, dehumidification, and high efficiency MERV 15 filtration device. Yeah, so like someone said, it's great for low load homes, but also for any kind of homes where it can be used as a fantastic set of lungs, doing whole house balance, fresh air ventilation, whole house dehumidification, because we remove up to 112 pints of moisture per day, and also whole house MERV 15 high efficiency air filtration. Yeah, so that's for the quick 15 seconds.
Yeah, no, thank.
Yeah, and please put a link in the chat box to your website.
I will. Thank you.
Yeah, and we didn't really talk much about Nikki represents Therma-Stor with a couple of different products. Not to make this products central, but just I think you have some interesting high performance humidity control devices. Do you want to talk about those for a minute, Nikki?
Sure. So there's a gentleman named Ken Gehring, which if you've been in the building science arena for a long time, you probably know him. But he invented the Ultra-Aire whole house ventilating dehumidifier, so the first ventilating dehumidifiers. And then we also have the Santa Fe, which are the basement and crawl space dehumidifiers. So we were really the first ones with those horizontal dehumidifiers for crawl spaces, extremely energy efficient, MERV 13 filters. So yeah, I mean, we've definitely been doing it the longest in the industry and know the applications. There's a great study that just came out July of 2018 from Hvac. Oh, there you go. Thanks, Blake. You just got one. That talks about, they studied a lot of ways to install the dehumidifiers, and basically the study, the result was that, you know, don't do a return to return install if at all possible. So that's a great study that I can try to find and put in the link here to really show the most energy efficient and effective way to install one.
No, that'd be great. Thank you. Any other questions we didn't catch on the chat?
There's probably about 1 million that just came through here on the end. It started to get a little crazy. So
yeah. Or yeah, how about this is one that comes up for me a lot from Nolan. How does a product like AeroBarrier or AeroSeal, yeah, it's AeroBarrier is the name, affect indoor air quality? Is there any off-gassing versus air exchange control? Does anybody want to, does anybody have any expertise at all with AeroBarrier or want to say something about it? I don't have firsthand experience, but I've been paying attention to it.
You know, I don't know anything about AeroBarrier when it comes to off-gassing in the product itself affecting indoor air quality. But I think, given that question, I think we could point out that fact that air sealing is an important aspect of being able to control healthy indoor air quality, right? And one of the things that we've learned is that as an industry is that when we actually build houses that are well air sealed, then we can actually ventilate well and control that ventilation and filter that air. And if we're not air sealing our houses, we don't know where air is coming from, when it's coming in, when it's going out, and we don't have that control we don't have any control over indoor air quality if we just have a big old leaky house. So I can't speak to AeroBarrier in terms of its off-gassing, and it's a good question. I'd like to know more about that, but air sealing is definitely going to help you in your fight for healthy indoor air quality.
Right.
We had, go ahead, Mike.
Well, yeah. So just build it tight and ventilate right is pretty much always the mantra. What I understand about AeroBarrier is that it's acrylic. It can span up to 1/2-inch gaps, and Travis, have you guys used it? Or I know Jake used it.
Jake used it, and I was there for the blower door test the day after. And then Joe Nichols, who is the third founder of the KCBS and beer. It's me and my partner, Joe Cook. And then Joe Nichols runs Thrive Building Solutions, which is an AeroBarrier vendor. So we had him present at one of our local discussion groups on the product. And Mike Wedman, who was on last week's meeting, I'm not sure if he's on this one, is a builder in Lawrence, Kansas, who has used it a ton. And we got deep into the weeds on this stuff about environmental impact and about performance. And the performance data held up with what you were talking about, the 1/2-inch gaps. You can basically cover a multitude of sins with that product. And as you said, it is acrylic based. The manufacturers, and I think someone even put in the content, mocked architecture, doesn't off gas. It's basically like a latex paint. Very, very similar properties. During the aerosol phase is the only time that it's really a potential hazard, and otherwise not. So yeah, I feel confident about it.
On the podcast I recorded with a narrow barrier tech in Oregon who's been doing it for a year, and one in Rhode Island, which will be up on the podcast next week. And they talked about that. And they both basically said, you know, during the installation is when you wouldn't want to breathe it in, but they've done extensive testing apparently, because their parent company is ductwork sealing. And so that's been around, I think, for considerably longer. And you would think that if there was any kind of major impact with ductwork and providing air to certain areas, they would have done some of that. So, so more up on the podcast from both the East and West Coast aero barrier installers, and to reach out to either one of them. I'm sure we'll provide more information for anybody that has questions on that.
Yeah, and I think if I recall, Travis, Jake Bruton's project they went from like 1.0 ACH 50 to 0.2 or something. Like it was quite a significant.
It was kind of obscene, the improvement. Although Jake's house, I think the aero barrier was done before the windows were in, so that makes a big difference too. But yeah, I think that house is now occupied, and they tested it after, and he's still below passive house standard. I think he was like 0.53 or something.
Yeah,
really good number.
Randy, who runs the BS and Beer Group in Minnesota, said it. He went from 0.3 down to 0.03.
There you go.
So half the passive house standard, which is about 4 times as hard as the passive house standard.
Yeah, the way they work is they go in, and when they're doing a job, they ask you, what number do you want to end up at, and they dial that in, and that's where they get you. If you want 0.04 ACH 50, they'll get you to 0.04.
Wow, that's great. Dan Kolbert had a good question. He has a column in our local green building magazine, Green and Healthy Maine Homes, called What's Your Number? So he asked what are good numbers for indoor air quality. I think that's what it was. I lost the question.
Yeah, what are the good metrics? Actually, I was just gonna, you read my mind. I was just gonna say the same thing. Does anybody have a resource for what are good metrics for indoor air quality? Where I don't know if it's, you know, EPA or process that you've experienced, or the WHO. Right now people are looking at requirements, but if anybody has a suggestion and a link on good metrics.
I'll start with some of the most important ones. So carbon monoxide, 0. You want 0 carbon monoxide in your house. And to do that, to know that you have really low carbon monoxide, you need a low-level carbon monoxide detector, not the ones that you get at Home Depot or Lowe's. Those will not tell you anything until you get to 70 parts per million for 2 hours. So the UL-rated ones are no good. I mean, they are good, but by the time you get those things start going off, you've been in trouble for a while. You want a low-level carbon monoxide detector. There are a few out there. And so water vapor, you want low humidity in your house. So with normal indoor temperatures, you generally want, we showed the graph, and generally want between 30 and 60%. Don't go lower than 30, don't go above 60. And let's see, carbon dioxide. There's no real hard and fast guidance on this, and most of the places I look in, like in the 2 ASHRAE standards for residential ventilation, 62.1 for commercial buildings and 62.2 for residential buildings. They don't say anything about carbon dioxide. They don't give you any recommendation for, you know, how high it should be or how low it should be. But generally, if you talk to people in the industry, they'll say that 1,000 parts per million is what you want to stay below. And again, with the caveat, if you're using one of these, you know, Fubot or a Purple Air or something like that, you can't trust those numbers. There's a lot of uncertainty in those numbers. So it may say 1,200, but it could actually be 900. So those are the 3 of the big ones. On VOC, PM 2.5, there are numbers out there. I don't know what they are, but those are the ones I know, the big ones.
I'm not sure how they're doing it or what they're requiring, but I believe that the Living Building Challenge program is requiring indoor air quality testing before occupants move into the homes. Does anyone know any more about that?
All I know is what I heard on the Green Architects Lounge podcast about that. And I thought it was, if memory serves, they did a test prior to occupancy, and they do a lot of follow-up testing with that program, if I'm not mistaken, to make sure that things are being maintained and performing at the same level.
I think that's one of you make a good point there, is we design things to work one way, and then we put people in those houses, and then the houses don't perform the way we designed them. We see that a lot with the relative humidity side of things, that, we sized the system correctly, we did everything according to best practices, and then the people moved in and they're not running the AC or the way that we expected. And that's the same with, all of indoor air quality. It's, we hope that people live in their homes as VOC and as indoor air quality positive as possible. But the reality is that's just not how it works.
Build the best quality house, best engineered house, and the worst thing we can do for it is let somebody move into it.
Yeah, people screw up houses. That's what happens. Everything works till people move in.
Dan keeps asking questions, but we can probably let's do one more Dan's questions, and then we'll shut things down. He says the Hvac measures CO2 equivalent. Does anybody know what that is, and is it worth it? What is CO2 equivalent when it comes to air quality? You know what it is for climate change, but so I guess the question, or I think another way to say the question, I think I remember hearing Joe Stieberg say that CO2 is a good, just like for climate change, CO2 one to measure. So it's prevalent. So it's a good indicator, even if it's Mike, not as dangerous as like methane. Yeah.
Mike, I unmuted myself. I hope that's all right. I'm looking at a Hvac dashboard I have now, open now, and I'm going to put some pictures of what I'm looking at up in your in the Facebook group. But basically, the CO2 tracks very closely to the TVOCs, so they're kind of just running algorithms in there.
Okay.
I wouldn't put too much
the
time.
canary in the coal mine for everything else in the house.
Yeah.
Got it. That makes sense. Doug Horgan, who's a building science builder in the DC area, Hvac CO2 equivalent is widely known as a bad measurement. But yeah, I think as usual, we're not going to come to agreement on building science topics. We can just talk about them. I think let's wrap things up. Unless anybody has any last minute things they just have to get out, let's call this good for this week. Thanks again to everybody for joining in. This is here for everybody. So join us again next week. We'll be doing it again on Thursday. We may push back an hour next week just so it's a little easier for people across the country. And have a great night.